Hi, Elizabeth.
Hi, Professor Clausen. How are you?
Good. How are you?
I'm good.
Good. Are you ready for your final? Is it today? It is 4 o'clock.
4 o'clock. I will see you there.
I'm so excited.
Yeah, I think this time, now knowing like what the midterm was like, I think I'll know what to expect for the final.
Good, good.
Yeah. Do we need any handout? Like, I know we need stuff for class today, but do we need any like specific handouts to pull up?
Let me look. If you want your percent one up, I think that's homework that's due today, is it? The percent fractions.
Let me see. Sorry, I'm pulling up my dashboard.
Yeah,
I know which one I know which one you're talking about. So today, yeah, the percent homework, fractions, decimals. It says percent again.
Yeah, I don't know why.
But yeah, it's that one.
Yeah, so if you want that one, we're going to use part of that today. I don't know. It's so funny, Elizabeth. Before I had everyone on my screen, and now I literally only have Elizabeth on my screen. I don't know why. It's very fun, though. You're like this big. Let me show you. I have, I don't know, probably a 32-inch monitor on my desk, and it's literally 32 inches of Elizabeth.
That's terrifying.
Well, it's just funny. I don't know how I did it.
Yeah, I know.
I literally have no idea how I did it. Now I fixed it, but I never got rid of you. I like just had to move you to another screen. Now I have everybody and you. So, I mean, very interesting.
Yeah. At least I don't like goof off during class, so you can't see me doing stuff like.
Well, it was funny because something weird might have been happening in my last class, because this one girl, all she sent me in the chat, they were chatting me answers to things, and literally all she sent me was OMG. And I was like, oh, do you think she meant to send that to me, or was she talking to somebody else, right? Yeah. Or what happened? I don't know, but it was kind of fun.
It's funny. I was talking to one of my roommates today, and she was saying how her class like has their own like a server, and they all talk to each other during class, and they're like, what is this professor doing? Like, it's just so funny to see. Yeah.
Yeah. I don't know what was happening. I was trying to let Shayla in, and it wasn't letting Shayla in. I don't know. Oh. But now it did. How is everybody doing? Is everybody so excited for finals? Yay! Yeah, me too, Shayla. I can see it on your face. Didn't you like my final exam oral questions? They were fun. I liked them. Yeah, they were good ones.
Can I ask a question actually about number 1 for the oral question?
Maybe. What's your question? Is it vague enough, or do you need to type it to me?
I can, here, I'll just type it to you just to be safe.
Okay.
But, all right, this will take me a minute, but just be patient.
I will try. Okay, I'm going to put up questions on the screen, and I want you to think about how, and try them, how you would do it. So it's some decimal problems, but I say I want you to use a non-traditional method. So I don't want you to line them up, right? And do it. You could do base 10 blocks, you could do fractions, right? You could do estimation, those kind of things. So I will put those on the screen. Oh, we were supposed to meditate for a minute, 3 minutes. Do you guys want to do that? I just forgot. We better do that first, because I shouldn't forget that part. Emily. I'll put these on the screen for just a second while we're waiting, because a couple people are still arriving. So, and if we are meditating, it's a little irritating when we hear that ding dong doorbell. Okay, I just got kicked out of my own meeting, so I'm not here anymore. You're welcome. I mean, I am, but my iPad's not. Okay, so there's the, can you see my screen now? Yes, okay, good. There's the 3 decimal problems that we're gonna talk about in just a minute. And then I'm gonna pull up, so if you just wanna screenshot that or write them down real quick, and then we're gonna do our little Mindful Monday activity because we probably all need it on such a stressful day and week, right? So write those problems down real quick. Who's Bella? Have we done this before? We're going to be risky and let them in, okay? Ready? Out. You're good. Hi, Ashley. Okay. So there's those decimal problems, but I'm gonna show you, we're gonna do a breathing mindfulness Monday exercise. So I'll put these up again after. You do not have to do the decimal problems while we're doing our Mindfulness Monday. And I will tell you, I will allow you to have your cameras off if you want during Mindful Monday because it asks you to close your eyes. And I don't know about you, but I feel a little weird like this in front of all the video screens. So I'm still saying close your eyes, but you can turn your video off when you do that part. Okay, so hold on one second. Let me get the video ready. Okay, now go ahead, you can turn off your video if you want, but really try to do this exercise because I'm pretty sure everybody needs it today.
Mindful breathing. Close your eyes and rest your hands on your knees. Bring your attention to the touch of your body on your seat. Feel the weight of your body on your chair or cushion. Make sure that your back is straight and that you're comfortable. Take a few deep breaths. While you're breathing deeply, relax your shoulders, your stomach muscles, the muscles in your face, your hands, and your legs. Let go of all the tightness in your body. Now bring your attention back to your breath. Notice what it feels like as it enters through your nose, goes down through your throat, filling your lungs, and back out through your nose. Notice your stomach and chest rise and fall each time you breathe in and each time you breathe out. And just allow your breathing to be natural and relaxed. Now bring your attention to the feeling of your breath in your nose. Feel your breath as it comes in and goes out. Just focus on this sensation, paying attention to each time you breathe in and each time you breathe out. As you inhale, maybe your breath feels cool. And as you exhale, maybe it feels a little warmer. When your mind wanders, or if you become distracted, just notice what's going on in your head, and then gently bring your attention back to your breath, going in and out. Focus on the feeling of your breath and allow thoughts and feelings to come and go in the background. Now gently bring your attention back to the touch of your body on your seat and open your eyes.
All right. So I hope you're not asleep after that, but some of us really need that reminder, right? I don't know if you do, but I definitely do. Like in the middle when they said, when you get distracted, I was like, oh, yeah, that's me. I actually am distracted and I'm the one who played the video. So it's good. And the other thing I noticed is when they talk about feeling your breath in your chest, but also in your stomach. I don't know about you guys, but I like hold my stomach in a lot unknowingly. And I think it's because I'm uptight about things. And when they remind me and I relax, I go, oh, that does feel different, right? Like, so if you needed that minute, do you remember when we talked about our anxiety and our test anxiety, and people who meditate 10 minutes prior to a test do better on a test? That was research based. I'm not saying change it up. Like if that's not you, don't do it today if your final is today. But if you just keep this in mind, I have to be reminded of being mindful all the time because I am a little high strung, you might have noticed, and I do a lot of things. So I get very caught up in life and I need to settle down and focus on being right here, right now, so I can really be ready for whatever the experience is in front of me. Okay? All right. All right. So am I still sharing my screen? Can you see the decimal problems now? Yay, I changed things up. Now you can see my iPad and I don't have to see it on my screen, and I can see all your wonderful faces still, and I still have my laptop for other things too. So I figured it all out. So I know it only took me 8 weeks. You'd think I would have been smarter than that, but it's okay. At least it didn't take me 8 weeks in one day, right? We have to be excited for those little things. Okay, so did anyone try these alternatively? Try them now, and I'll give you maybe 2 more minutes to do that. Elizabeth, I'm not ignoring your question. I'm just looking at it.
That's okay.
So were you sure you were asking for number 1 from the oral exam question? Because that's the chip model question. Number 1 on the oral exam is the chip model.
No, it's not.
No.
The
Mine came up as the chip model was not number 1.
Yeah, the chip model is number 2 on mine.
Oh, I must have rearranged them and not told myself. That's so fun. Okay, so this will be, I will have to correct that before I get everybody's. Okay, so what is number 1 on yours? Oh, is it the multiplication problem?
It is. It's something like, it's something
see.
times 17.
Yeah, and it just says use an alternative method.
Yeah, so the method that I sent you, I just kind of need clarification on why we.
I'm not going to explain that to you, but I will tell you, do it traditionally and you'll see why.
Okay.
Do it traditionally and then you'll figure it out. Oh my, I'm so happy you guys asked for that because now I can rearrange all my questions. Okay, not funny. All right. Did you guys do at least one of those problems? Okay, excellent. Who would like to share how they did any of them? I don't care if it's A, B, or C.
I can do A.
Oh my gosh, Savannah, Missy. Oh, your hair is behind your back. This is so funny. I just had a flash.
Oh, yeah.
Your hair was cut like this short because of the picture behind you. That was terrifying. I was like, I mean, it looked very cute, by the way, in case you ever want to get your hair cut to here. But
oh, see, my mom did that to me when I was a baby, and I cannot. I'll never.
Yes, that's traumatizing. I love your long hair. So, but if you wanted to get it cut, I'm sure it would be fine. Okay, go ahead and tell me which one you want to explain.
So I did the first one. I didn't get to finish the second one yet, but I did the first one, and I kind of drew out the picture for it. So I did the 5 boxes, the four longs, and then was it 7? Yeah, the 7 X's, and then I added the 4 boxes, the 7 again? Yeah, 7. Oh yeah, so the 7 longs and then the 8 X's, and then so I was able to see that with these X's I was able to create 1 long, and I was left with 1, 2, 3, 4, 5 X's. Then I moved on to my longs. So I added 1 long to this top row. So that gave me 5. So I was able to add 5 more from down here. So that left me with 2 longs. I was able to create this one, a cube, and then that left me with 9 cubes. I'm sorry.
Nice, very nice. The only thing I will recommend is you call the X's units. And you did great calling them longs for your 10s in this case, longs. And then the boxes, don't call them boxes, call them flats.
Flats.
Okay. Yeah, flats. It's okay. You're doing good. And so Savannah used base 10 blocks. So did anyone else do that one differently or use a different strategy on the subtraction one?
I used fractions.
Ooh, fractions. And Tintu was going to say something else. Were you going to use fractions, Tintu?
I used fractions for both of them.
Fractions, yeah. Okay, Anaka, I'm ready.
I put 47 over 100 minus 370 over 100, and then I got 169 over 100, which equals 169 hundredths.
Very nice. So you did 547 over 100 minus 378 over 100, and you got 169 over 100, right? Isn't that what you said?
Yeah.
And so you got 1 and 69 hundredths, or you said 169 hundredths. That's fine too, as long as you write the decimal this way. Excellent. Tintu, did you do fractions on the second one or the first one, or both?
Both of them.
Both of them. Did you get the same answer Anaka did?
Yes.
Excellent. Great. How about the multiplication one? Did anyone think of an alternative way to do the multiplication one? Because we talked about that a little bit less.
I did fractions for that one too.
Nice. You did fractions for that one. So you did this. Oops. Just kidding. And then you did 9 times 314, right?
Yeah.
Did you get 2826 over 1,000? Is that right?
Yeah. Yep.
Okay. Nice. Did anyone do that one differently? I've had kids do it like this. And then they know that it's thousands, so they just put their decimal point in at the end. So they treat them like whole numbers, right? Even though that's a little more traditional. So, and I have had students do it this way where they go like this. This is even more different. I've had students do this. I can't even do it, but boy, these kids who do it are amazing. There might need to be another 0 there. Yeah, there you go, like that. And I've seen kids do it like this and get the answer amazingly quickly.
I have a
So,
question.
yeah,
For multiplying decimals, do you not have to get a common denominator?
nope. Because do we have to get a common denominator in fractions
No.
when we multiply? Nope.
Okay.
Fractions and decimals are no different, right? It's just a different way to write the number. They're the same. So if you don't have to get a common denominator in fractions, you don't have to in decimals. All right. So moving on. Any other questions about that? Okay. Let's talk about this. You guys are still looking at my screen, yes? Thank goodness. Okay. So 3/4. Here's what I want you to think about. How would you shade that grid? Just think about it. You don't have to actually do it. If you're doing it on your paper, that's fine. But think about how you would shade it and think about how you knew which region to shade and then what's the decimal name for the shaded region. So just think about this first one. All right. So someone tell me how they would shade the grid. What would they do and how did they know how to shade it?
I just took 100 and divided it by 4. Because you said it was
Okay.
units, right?
Yeah, so how did you shade the grid?
I just shaded 75 of the units.
Okay, like across, up and down, how'd you do it?
I don't know, I just did it in my head. So I guess it would be 7 up and down and then 5.
Okay, did any of you do it this way where you shaded 7 of these and then you shaded 5 like that? Did anyone shade differently?
I mean, my thought process behind it was like kind of different. I thought about it when we were like I thought about it when we were using the 10, like the packet that we just had. I forgot what packet it was, but like I thought about it. So I did like different colors like in my head. So I put 7 like longs in orange like in my head, and then the 5 units would just be in yellow. Like that's how I
How
thought.
did you know it was going to be 75?
Because well, if for me, like when I see 3/4 I think of quarters because I'm always around money. So like I think of quarters. So 3/4 is 75. So
Nice,
3.
that's perfect. That's perfect, Savannah. That's what I want to get to is what was your thinking process? So Abigail's thinking process was do 100 divided by 4, which gave her 25, and then she did 3 copies of 25. You did not think of it that way. You thought of money, and you said, oh, if I have 3 quarters, I have 75 cents. Did anyone else think of it differently? Because this is really important.
Kind of.
Okay, go ahead, Natalie.
Basically, I just knew that 4 times 25 was going to give me 100, so that's how I found the 75.
Nice. So you kind of used the missing factor model instead of Abigail used division. You used the missing factor model and said, what times 4 gives me 100? Did anyone do their grid like this?
Yeah, I did like this.
Yay, thank you. Yes, excellent. So when we normally do this in class, so I hand out these grids and everybody just shades it and then holds it up. And you'll be amazed at how you see differences, right? Kristen, I think, said she shaded it like this as well. This is nice to split it into 4 sections and then shade 3 out of the 4. And then you go, oh, that must be 25, 25, 25. So that's 7,500. But it's just a different picture in our mind. Do you see? And not one is not better than another, but it's important to notice these differences between them. Yeah? Okay, so now that you know that one, how would you think of part B? Think of how you would know what to shade on part B. Okay, so think of that. All right, Sophia, do you want to explain it?
Yeah, so I might be wrong, but I think I did it right. So the way I set it up is like I didn't shade, I just did the math first, so I did
Oh, but that's not what I wanted you to do. I wanted you to shade first and then figure out your decimal. That's the idea, is how would I see it in a picture, so
Yeah.
then I would know what the decimal number is.
Well, then,
So pause for a second then, Sophia, and let's see who shaded first. How did you shade?
After looking at the way that you did it with the 4 quadrants, I knew that each quadrant was 25 units. So I shaded 7 units out of the 25 in each one, and I got my answer that way.
Excellent. So you split it like this. I don't know why my writing just turned atrocious. That's a little bit better. And then you shade 7 boxes in each one. And so you had 4 copies of 7, right? So you had 28. So 2,800. Did anyone shade it differently? No one?
I did, but it's the same theory. I shaded in like 4 rows next to each other. I just shaded 7 line, like 7 in each line.
So you did like 7 here.
Right.
And then 7 here.
Mm-hmm.
And 7 here and 7 here. How did you know it was 4 of the rows that you wanted to do?
Because the denominator on your fraction is 25. So if you have a total of 100, then 25 would go into that 4 times. So
Nice. Nice. Sometimes I see students do it this way. Exactly what Brittany said, but they group them like this. I'm trying to remember how they do it. They group them very strangely because they go like 25 and they'll put like a mark here. And then they'll go, that's not even 25, by the way. I need this grid a little bit bigger, apparently. There we go. I have students who go like this. Okay, 25. That's 25. And then they'll go 25. And then they'll go 25 and 25. I literally have students do this. And then they shade 7 out of each one of these 25. So it's the same idea, but they'll shade them very differently, you know? And then they'll get the same answer. So when you give kids the opportunity to explain their mathematics, it's really good, because you'll have all these weird different ideas come out and you'll be like, that's totally right. I love how you did that. And then of course you'll have someone else who does it like this, and the rest of the class will go, why didn't I do it like that? And you're like, it's okay, our brains work differently, right? So our processing is very different. So now we've connected fractions and decimals. Here's another grid, a couple grids. I want you to try these two. Please, please, please do the shading first. Yes, do the shading first, and then figure out your decimal number, okay? All right. So, Emily, do you want to explain what you did for part A?
Yeah. So originally I did 100 divided by 5, which is the denominator, and I got 20. So I broke the scale model into 5 groups of 20.
And how did you do that?
I did it horizontally, so I just did like
Okay.
10 and 10 a line, 10 and 10 a line. And then I shaded 3 on each of them, and then I got 15.
Nice. Who else did it differently?
I did it pretty similarly to what Emily did with finding out like how many times 5 goes into 100. But I did get stuck on the like, once I figured out how to break it up, like what to do with the 3. But
Okay.
it made sense how she shaded it in, which is probably what I would have done.
Now, is this correct, what I did here?
I did something different.
Emily, is that what you got for your answer? Is that how you did it?
Yeah.
Okay. So Abigail said she did something different. Kristen's saying that's not what I got, right? And Brittany's like, that's not what I got. Okay, so Abigail, what did you do?
I divided it the same way, but I shaded 3 of the 5 like fully, so 10, 20, 30, 40, 60
So
of them.
you shaded like this,
Yeah, 3 of them.
which would give us a different answer, yes?
Mm.
So what was, I like the thinking of Emily splitting it up into those 5 groups. Where was the flaw in the plan? Instead of just shading 3, do you notice when you shaded these 3, you were shading 3 out of 20? And that's not what this fraction is telling us. It's saying shade 3 out of 5. So what you could have done if you wanted to split it up that way is, I'm going to erase this so you can see. If you split it up that way into those pieces, you could have said, okay, so here's 5 boxes. So I'm going to shade these 3, and I'm going to shade these 3, and then there was my 5 right there. So then I'm going to shade these 3, and I'm going to shade these 3, right? And you could have continued with that pattern the whole way down because you were shading 3 out of 5. But I think where you got stuck was you were shading 3 thinking that each one of those sections was only 5, but there were really 20. Does that make sense? This is a legal way to do it right here. Because we'll get the same amount, right? If we have 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 30, here we have 30. We'll get the same 60. So do you see where that went wrong? And some people do it vertically too, right? Split it into 5 pieces. And then I do see, I'm going to do it on this grid so you guys can see, and then we'll go back to this grid in a second. I see students do this all the time. And then do what Abigail described.
I got the same answer as Emily at first, but then when I looked at it, I realized that it was wrong because 3/5 is over half of the whole, and that's not even half.
So great way to check it. Great verification, right? You're like, okay, I did get this 1500, but that seems too small, right? Because 3/5 is more than half, so I should have more than 50 squares shaded. Good catch. Good job. Any other questions on that one?
The way I looked at it was that there are 10 units in a long. So I was shading 3 units out of 5. So I did like the line down the middle. And then I started doing my 3s by each long. or by each half of a long, which was the 5.
So you did like this, you shaded 3 in each row or each column?
Each row.
Okay, like this?
Yeah.
So you get the same answer, right?
Yeah.
Good, but it's a different way of thinking. Okay, good job. Now, how about this one? This 11/20. This is one of my favorite ones that kids do in class. You'd be amazed the stuff that you see on these 11 out of 20.
I split
What
it
did
into
anyone do here? Go ahead.
I split it into 5 sections of 20 horizontally, how you had done the other one the first time. And then shaded 11 in each section. And I actually did a full row and then 1 extra.
Oh, tricky.
Yeah, I like to mess you up.
So this whole row and then 1 extra.
Right.
And then this whole row and 1 extra, and this whole row and 1 extra. So then you knew you had 11 in each section. So you had 5 copies of 11. So you had 5,500.
Right.
Nice. Anyone do it differently? So what you guys don't realize is you know a lot. And so when you start these activities, you think of it the way you already know how to do it. So you look at things like this and you're like, oh, 11 out of 20. How could I make that something out of 100? I could use my scaling strategy. And that would be 55 out of 100. So now I'm going to go over here and just shade 55 boxes, right? That's what a lot of us do naturally because we know all this information. But if you allow your students to explore these ideas, and by the way, what I usually have, and I don't have any here because they're still all in my office, I have grids on like laminated paper. It's 100 grids. And I hand them, and they're laminated, I hand them out to all the students and they can draw on them with dry erase markers, right? And they draw on them to show these things. And if you allow them to do that and you show all the different processes and ideas, the kids, the further you go, the more creative the kids will get, right? You'll have kids start drawing you pictures in the grid and they'll still be mathematically accurate. And so these conversations are great. But it's a great way for students to be able to say, hey, my thinking is usually off, but I really know what's happening. And it's so nice to finally see a teacher recognize that I know what's happening. I might think of it differently than everybody else in the class, but I do know what's happening, okay? So that's a really good activity. So fractions to decimals, there's different ways to convert from fractions to decimals, depending on how you like to do it. You could use long division, right? That's not a problem. It always works. Long division always works. But sometimes you can use powers of 10 to make your life easier. Yeah? So this does work with your team, but I'm just going to have you work right here for a few minutes. See if you can convert all of those to decimals without using a calculator. I don't want you to pick up your calculator. So try them all without using a calculator. Okay, some of them are easier than others. All right, when you're done, let me know in the chat. All right, so let's start talking about some of these. I know some of you might not be done with all of them, but when I look at these, I think some are easier than others. By the way, if I look really weird, it's because I'm standing up. My back has been hurting me, so I'm hoping that standing up is a better strategy for right now. But like my camera has to be like this because I don't have a taller place to put it. But I will get one, but that's why I look a little weird. You're like, you look exactly the same. You always look weird. That's okay. Okay, so for me, problems 1 and 3, I knew were going to be easier than the rest of them, right? So I did 1 and 3 first, and then I was like, ooh, 2's not too bad, but 4 is the worst. So I'll save 4 for last. So that's my opinion when I did them. And what I did was I was like, oh, 1 and 3, I can use powers of 10. I don't have to do long division. And if I can avoid long division, I will. So just so you know. So, but you guys might have done it differently. So Gabriella is going to do number 1 for us.
So I did long division. I can do a whiteboard or.
Sure. Let me see if I can stop sharing. Hold on. Go for it.
So it was 7 over 40. So I did 40, or 7 divided by 40. And I knew that couldn't go. And then you have to add the little decimal, then another 0. You know that 40 goes into 70 once. That's left with me with 30, but you still need to add another 0, bring that down. And then, you know, 40 goes into 300 at least 7 times for 280. And then you're left with 20. And then you bring down another 0. And, you know, that can go into 5 times equally. So, you know, the answer is 0.175. Oops.
Nice. How many of you did it that way? Long division. All right. So as much as you guys hate long division, that's your go-to strategy. That is worrying to me. Don't pick a strategy you don't like, goofball. Okay. So the other thing, we'll talk about some other strategies you might have used. Did anyone use what they learned from their repeating decimals packet about how do I know if this is going to terminate or repeat before I even do the problem? That would have been a good idea, right? So I could have said, oh, 40, I don't know if I can even write on your screen. Let me see. I could have said 40 is 2 times 20 is 2 times 10 is 2 times 5. So 2 to the third times 5. And I would have said, since my prime factorization of my denominator contains only 2's or 5's or both, I know that this decimal terminates. The other thing I know is it's going to terminate in 3 decimal places. Yes, that was your big discovery from the repeating decimals packet. Yes, and I posted my key. So if you didn't discover it, I discovered it for you, and you can read about it now. So it's going to terminate in 3 decimal places. That's nice when you start a problem because then you know how long you're going to be tortured if you choose to use long division. Did anyone not use long division on this one?
I didn't.
Brittany and Kristen didn't. Excellent. So, Brittany, what'd you do?
I'm not sure there's really a name for it. Basically, if your answer is over 100, then you know what your decimal is.
Nice.
So in order to get 40 to 100, I just multiplied it times 2.5. So then you have to multiply 7 times 2.5. And so then you have 17.5 over 100. So then your answer is 0.175. Not really sure.
Interesting. There is a strategy for that. That's proportional reasoning. So that was scaling. That's exactly what you did. You did scaling. Now,
Yeah,
I didn't do that.
I fall back on it for some reason. I don't know why.
No, that's not a bad thing. It's awesome. Kristen, did you do it the same way or did you do it differently?
It's kind of similar here. Can I show whiteboard?
Yes. Can you stop sharing, Gabriella?
Yes. Oh no. Where did it go?
Okay.
There you go. Perfect.
So I was thinking the same as Brittany, kind of, but I did it really weirdly. So, so I was thinking, well, I knew I was gonna try to get to 100, but I didn't know exactly how 40 could get to 100. So I was like, well, I know how to get it to 200. That might be easier. So I did times 5 over 5. And then you have 35 over 200.
And then how'd you know how to get it to 100?
And then, well, because 200 is, well, you basically have to divide both of them by 2, because to get 200 to 100, divide both of them by 2. So you divide it by 2 over 2. And you have 17.5 over, oh, that's weird, okay.
No, it looks perfect.
It's hard to write. I'm not using my laptop, so.
Yes, so it's a similar idea to what Brittany did, but a little bit different because you jumped to 200 and then halved it.
Yeah.
So that's a good strategy.
Then like on number 2, I went to 300 and yeah.
Oh, on number 2, you went to 300 and then you divided it by 3. Excellent. That's a nice strategy. I would never do those. So I love to hear these different strategies. Savannah, what were you going to ask?
So going back to like the way that Brittany did it, so I know she did the scaling and it was the 40 multiplied by the 2.5.
2.5. Yep.
2.5, yeah. So when she did it to the top and it equaled out to 17 and a half, like I'm kind of confused, but like at the same time I'm kind of not, because of since the 5 was already there and you know how it's in the hundredths, you just move the decimal twice, correct? Even though the 5 is there, like you don't have to worry about that.
Right.
Because like
so
my thought process was, wouldn't it be 1.75 hundredths? And then I was like, well, wait a minute, no, because the 5 was already there. So
good question. So if you take 17 and a half and you divide it by 100, that shifts your place value 2 to the left from where it is. So that's why it ends up in front of the 1. Does that make sense?
Yeah, it makes sense now, but like
no, that's a great question, because before we read it as, oh, it would have said 17 and a half hundredths, so we want it to end in the hundredths, but it's a little confusing because there's a decimal in that numerator.
Yeah, okay.
Great question. Okay, did anyone else do it differently? Of course I did. Are you shocked? Yeah, I'm sure you're not. I did it like this. I can't even remember the original problem. What was it? Oh, I have it in front of me. 7 over 40. I knew I couldn't get it to 100 easily, but I could get it if I multiplied. I know that 4 times 25 is 100. So if I multiply 40 times 25, I'm going to get 1,000. And then if I multiply 7 times 25, that's really nice because that's just quarters. right? If I have 7 quarters, I have $1.75. So this is how I did it. And then I read that as 175 thousandths, which gives me that. So I just used powers of 10 to get me there. So similar to Brittany, but I'm not good at multiplying by decimals. So I want to make my life as easy as possible, right? So the fewer steps I have, the less likely I am to make a mistake. When I put in multiple steps, I'm going to make a mistake inevitably because I'm very good at mistakes. Okay, excellent. So now, hold on. Let's go over some of the other ones, because some of you might be like, oh my gosh, people in this class have the strangest ways to do things now. That's what the beauty of this class is to figure out those strange ways that we do things. So on number 2, Kristen already shared that she went up to 300, right? So on number 2, so you did 5 over 6, and you said, okay, how is that 300? I'm going to multiply that by 50, right? And so then you got 250 over 300. Is that what you did? Okay, and then what did you do after that, Kristen?
So I divided both of them by 3, and so then I had to do like a little long division, and I got 83 1/3 on the top. Yeah.
So 83 1/3. So you had 83 1/3 over 100,
Yeah.
right? And then so your decimal would be 0.83.
Yeah.
And then what did you do then? How'd you handle that other part?
Well, I know that 1/3's 0.333 repeating, so I just
did you do that?
Yeah.
Okay. Nice. Excellent. So that strategy works great for Kristen. Sounds hard to me. So it's not the way I would do it, right? And if you looked at this denominator, you might go, oh, the prime factorization of 6 is 2 times 3. So I know because this 3 exists in my prime factorization that this is going to be a repeating decimal, right? So in my opinion, when I do these, if I know it's a repeating decimal, I'm just going to do long division almost every time, right? So I do my long division right away because otherwise I'm going to make a mistake. And here I see right away that this 3 starts to repeat. So that's how I did that problem. I'm not saying it's right. I'm just saying like it's not the best way to do it. It's just the way I did it. Okay, anyone else do it differently? How many of you just did long division on the second one? Yeah. Sometimes you're like, I did long division on all of them. Well, that's fine if that's your strategy, right? A lot of you are that way. I do want to show you, if you did long division on all of them, look at number 3. You made your life so difficult. Who did not do long division on number 3?
I didn't.
Yay. Explain to me what you did.
Scaling.
So what'd you do?
Okay, I actually pulled a whole out first.
Oh, okay.
So then I was left with 3/5.
Okay.
And then I just like saved the one for later. And so then I did, because it's a 5th, like as we showed on our little, then if you multiply the top and the bottom by 20, then you're going to end up with 60 over 100. And then, so that's your decimal, but you can't forget about your 1 that I pulled out earlier. So it's 1.6.
Very nice. Excellent. Did anyone else do it differently? Not long division, but differently?
I did it like that, but I just didn't pull out the 1 first, so I just multiplied it by 20 over 20 and get 160 over 100.
Oh, nice. So she did by 20 over 20 and got 160 over 100. So then we would still get that 1.6. I only did it by 10. So I mean by 2. I did it like this and got 16/10, which still gives me the same answer, right? Anyone else do it? Yeah, Sydney.
Okay. I mean, like, I think maybe I just know this already, but I'm like being like having a dumb moment. But so Brittany got 1 3/5. Is that because she like took the 1 and made the 1 a whole number, and then there's 3 more? She took away 3 from 8 and got essentially 5/5.
Yep. So basically, she did like she didn't get. She said, okay, 5 goes into 8. How many times? 1. And then there's 3 left over. So when you change this to a mixed number, you get 1 3/5. Or you could think of splitting it up like this.
Oh my gosh, I was having a blonde moment. I was like really trying to think about it. I'm like, oh my gosh, how would she do that? Okay, sorry.
No worries, no worries. Okay, so this one was the long one, right? This one was the one that was a pain in the butt. And I should know that already because my denominator is a 7 and the prime factorization of 7 is just 7. So that's going to take a lot of digits to repeat, but it will repeat, right? So you did long division. So 3 divided by 7. And you're like, oh my goodness, how long is this going to take? It's going to take a while, right? Because I still haven't seen the same number yet. To be continued over here. And then we start all the way back over. Do you see how it goes all the way back up to here? So this is what's repeating. 4, 2, 8, 5, 7, 1 is all repeating. Yeah? Tricky? And so I don't know if anybody else had a different way to get that, but I only know of long division. Okay. So converting from decimals to fractions. We've talked about this a little bit already, I think, and some of them are easier than others. Like this one's not too bad, 125,000. And then I simplify 4/10, and then I simplify 1, or I could put 109 over 100, and that's simplified, right? Like that's fine. This is the pesky one, right? And some of you might not know, how do I change that from a decimal to a fraction? And on some of these, they're very hard to remember. But do you remember when we did our repeating decimals packet is if I have the same number repeating over and over and over again, that means there must be a 9 in my denominator, right? And the number that's repeating must be in my numerator. So that's 3 over 9, which simplifies to 1/3. But most of you probably just went from here to here and said, I know that if it's a repeating 3 to the right of the decimal, it must be 1/3. But do you see how this really helps make sense of why? Because you did that repeating decimals packet? Yeah. Okay. So I don't think I want to spend too much time on that. But percents, I do want to talk about percents. Most people are okay because they connect decimals and percents very easily, right? So we want to connect fractions, decimals, and percents. If you're given a percent, how do you convert it to a decimal? Somebody tell me a procedure they learned.
Multiply the decimal by 100.
So you want me to multiply this by 100?
Yeah.
Yeah, 42 times 100, is that what you want me to do?
Oh, from percent to decimal, right?
You would divide by 100.
Yeah.
Oh, divide by 100. Now, let me tell you just a little trivia. I don't know if a lot of you know this, but per means division, right? That's what per means. And cent means 100, right? Centuries, think of centuries or how many pennies are in a dollar, right? All of those things. So it means it's divided by 100. It's per 100. Now, did anyone notice this right here? It looks like a division sign kind of turned on its side. Anyone notice that? Or it's a 1 and 2 zeros. And nobody's making that shock face. Everybody's seen that before. Everybody just thinks mathematicians don't make stuff up because they think it's fun. Yeah, that's what it is, right? Did everybody get that? It's crazy, right? Why did they put a line like this and a 2 zeros right there? Because it means 100. Why does it kind of look like a division sign? Because that's what we're doing. Crazy? It is crazy. Okay, so 42% means 42 out of 100 squares, right? So that's what we're talking about. So 42 divided by 100 just shifts your place value 2 to the left. Yes? So you divide by 100 to change a decimal to a percent. And to go the other way, we would multiply by 100, right? So if you have a decimal and you want to go to a percent, that's what Sydney was explaining to us before, you would multiply by 100. Now, how would you make them a fraction? How do you make a percent a fraction?
You divide by 100.
There you go. Just write it over 100 and then simplify your fraction. That'd be 21 over 50. Boom, I'm done. Yeah? Not too bad? All right, so where does it get bad? It gets bad when we have something like this, right? Like on your worksheet that's due tonight. Yeah. So it says convert this to a decimal and a simplified fraction. So, and now you see decimals inside percents all the time, but that really shouldn't happen. We should really use fractions inside our percents. That's why, did you notice on that worksheet, it says, make sure that you have fractions in your percents. It said you can't have decimals. Did everybody notice that? If you didn't notice that, make sure you go fix that. Yeah, do you know what I'm talking about? Do you have that percent worksheet? I thought I put it right here. Here we go. I'll open this so you can see it. Right here, it says you can't use repeatends here. You must use fractional remainders. Yeah? Okay. And then in the decimals, we don't want any fractions in our decimals. Okay, oh look, we did this one in class today. 7 over 40, that was convenient. Oh look, this one, we kind of did too, right? Yeah. Oh, look, we did 5, 6 too. I'm so nice to you people. All right, now this is the one we're starting on right now, right? The 66 2/3. Everybody okay? You following along? Okay, so our 66 2/3, probably you know that 2/3 could be written with 9 as a denominator. Using scaling, we would know that 6 is our numerator. And we know from our repeating decimals packet that 6 over 9 is this, right? We know that because of our repeating decimals packet. So as a decimal, this is what it's going to be. What would it be as a fraction if we're going from, remember this is our percent, then we went to our decimal. What is it as a fraction? Brittany?
2/3.
2/3. Do 2 divided by 3 on your calculator. Don't you get 6.6 repeating forever? Yeah? Yeah, tricky, huh? You were like, that one seems hard, and now it seems not hard. Yeah, that's what happens. How about this little tiny guy? 0.5%. So how many of you know that 1/2 is 5/10? You know this, right? You believe this. Okay, but I'm not going to write this as my decimal because of that pesky percent sign. I have to divide this 5/10 by 100. What is that going to be? Somebody say it mathematically, please. I'll be so excited.
5 thousandths.
5 thousandths, yes. So that is 0.5%, yes? Do you agree?
Is that what you want us to show for work on this page?
Yeah, that's fine. As long as you're showing something like this,
okay,
like all of these steps, you're fine. And you're doing it on separate paper, right? Because it won't fit in those boxes. Okay, and then the last step, how do I make this a fraction? Read it mathematically.
5 over 1,000.
5 over 1,000. And that's going to simplify, yes, into 1 over 200. This page was not near as hard as we made it, was it? We like to make it very, very hard, even though it's not as hard as we like to make it. Questions on that?
Yeah, what do you want us to write for the answer on that? Is it just 1 over 200 and that's the answer?
Yep, 1 over 200 is the answer to the fraction. Yep.
I don't
So
understand
now, go ahead.
the one with the 66 and 2/3%.
Yeah.
Like, where did the 66 go in all this? Like in your 2/3.
So remember, so if I write 2/3 as a decimal, I'm going to get this forever, right? And then when I multiply it by 100 to make my percent, there's my 66.
Okay.
Because I multiply it by 100 right there to get it to a percent. Does that make sense?
Yeah.
It's a little bit tricky.
So the fraction part would just be 2/3?
Yep. Okay, so you have to do this one, this one. Oh, did we do this one already? I feel like I did it earlier in the slide. I'm so nice to you. All right, so you have 3 left if you didn't do those. Okay, we're going to talk about tape diagrams more tomorrow in our thing. Did you guys watch my tape diagram video? Nice. If you didn't watch it, watch it. It's not very long. What, 5 minutes, 4 minutes, something like that? Yeah. And some of you still got tricked on the last problem. Ugh, please read carefully when you do that tape diagram assignment. Okay, so I'm going to do one of these right here. If we want to do this, 30 is what percent of 75? This one's a little bit trickier. So here's my tape diagram. I'm going to say my whole thing is 75, yeah? My whole bar is 75. Down here, it'd be 100%. Here would be 0%. Now, I need to split this up so I can see 30%. So I don't know how to do it other than break it into 10% pieces. So I'm going to break it into 10 pieces. So there's half, and then I'm going to have 4 lines. And I know each one of these is counting by 10%. And so this is the line I'm most interested in right here. So if I have 75 and I want to break it into 10 sections, when I divide by 10, it only shifts my place value once. So this must be 7.5 in each one of these. Does everybody see how I got that? I don't do hard math when I do tape diagrams because that hurts my brain. I'm not good at that. I'm not good at the hard math when I'm drawing pictures. I just do easy math. Okay, so here I have 7.5. If I have 7.5 and 7.5, that must be 15. And then if I add 7.5 more, that must be 22.5. So it's 22.5%. I labeled this backwards, didn't I? Hold on. Did you see what happened there? I'm not saying I'm completely off, but I'm saying maybe I should read the problem. It wasn't 30%. It was 30 is what percent? That's a different question. So here's 100%. Here is 0. If it said 30%, that would have been a different problem. 75, 0. So here's what I have to do. Somehow I have to break up 75 so I can see the number 30. The only way I can do that in my brain is break it up in pieces of 5. So this is 5, 10, 15, 20, 25, 30, 35, 40. I'm going to run out of room. 45, 50, 55, 60. Oh, I'm so close. 65. 70 and 75. Now, this one's a little bit ugly, right? So 100%. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have to break 75 into 16 different pieces. That's not going to be pretty, is it? Right? So let's do easy math. If I do 5, it's too big. If I do 2, it's too small. Maybe 4. What do you think? 4, 2, 64. 1, 11. So I'm going to have 4, remainder 11. That's going to be ugly. Why on earth did I pick this problem? I don't know. Who knows? This is going to be 4 and 11 sixteenths. And I need 1, 2, 3, 4, 5, 6 of them. So 6 copies of 4 and 11 sixteenths. That's hideous. Who made up this problem? I do not know. Some crazy person. So the other ones turn out much nicer than this. So good thing I did the bad one, right? So let's see. 4 and 11 sixteenths times 6. I get 28.125%. That was a weird problem. That was not an easy problem with a tape diagram. I apologize for that hideousness. Okay, we're going to do more tape diagrams tomorrow, so they'll make more sense to you. I'm going to put your exit ticket in the chat. I don't think your exit ticket is too terrible. And then I'm going to see a lot of you today for, what is it called? Your final. Yeah, that's what it's called. Okay, this is a really long link, but the QR code should work. So sorry about that horrible one, tape diagram.
I do have a question about today's assignment.
I'm ready.
Yeah, so for the part to write the percent, I'm still confused. Do you want me just write the fraction, or I can just if it's not repeated, can I just write the decimal like percent something?
No, you always have to write a fraction.
Oh,
So like on which one are we talking about?
like the one like the number 7, because I know the fraction. Mhm.
Yeah, you should just write 12.5%.
Oh, okay. Oh, I see. 12.5.
Natalie, I'm looking it up right now, okay?
Okay, yeah, I was just wondering because I kind of want to go like still the education route, like with social work, but I'm just curious.
Let me look. Nope, you just need math 1-4x. Did you take that already? Did you take 1-4-1 or 1-4-6?
Is that just college algebra or?
No, it's college mathematics.
Okay. I'm not sure. I'll have to check.
It's with probability and statistics and counting. What's your last math class you took?
I did a dual enrollment in high school, so I probably don't have that one.